Welcome to my online channel, The Palm Leaf. This is the seventh video in the data analytics and visualization series. This is going to be the last video for covering the basics in the dplyr package. Just to run through a quick recap, in video number 5, we looked at the select function, which was used to select different types of columns in a data set, followed by the filter function, where you can actually do a Excel-based filter equivalent of different aspects from a particular or different kind of variables or different kind of values um, within rows. So while the select function is used to select columns, the filter function is to weed out or weed in different values in a row. We also looked at the chaining or the pipelining function, which is the two percentage values with a greater than sign in between. This was used to sequentially look at different lines of code so that you can logically think it out in your head, and it's easier to write and easier to read. For example, you could just use the data set variable and then put a pipe function, use a filter function saying that a particular column is equal to a particular value, again use the pipe function, and then use the select function to select the rows that you want, right? Then we also looked at the basic sorting function. So it is called as arrange. You could select but few rows and then arrange those rows. You could select certain columns and then you could arrange them by in ascending order or in descending order, depending on how you want it. We also looked at the mutate function, which is essentially to create a separate column and then put a value onto that column depending on the other rows. So if you have got two columns like CTY and HWY, and if you want to create a new column called as ratio, which is A divided by B, then you can obviously use the mutate function simply like this, right? In video number 6, we looked at the summarize function and the summarize each function appended with group by. So we could use the data set and then group by a particular column and then use a summarize function. So you could run into different statistical attributes for different columns using the summarize function. You can use the mean, median, the count of variables. So both COUNTIF and SUMIF is catered to. You can use multiple functions using the funds variable if you want to use it across multiple columns. So essentially, whatever you can do on an Excel sheet running pivots, you can do in R by writing a couple of lines of code. We also looked at the n and the n distinct function to look at the count and the unique level in a particular column. We looked at the table function if you wanted to understand the frequency of a particular column. And that's where we stopped in video 6, right? So in this video, what we are going to do is we are going to just go one step ahead and try to see the min rank function and the top n function. Both are essentially going to do the same thing in this example number 10. And then we'll look at the lag function, a few sampling functions, followed by looking at structure and glimpse functions, right? And that's where we'll close the dplyr function. We'll not get into the database side of things, at least in this video. Hopefully, in one of the future videos, I'll cater to the database functions. Right. So very quickly, I'll just run this line of code, what you see in 154 to 156, and then I'll try and explain. Right. So what I'm trying to do here is, again, this is a data set, the same MPG data set that we have been using so far. It is, just to do a quick recap, it is just it's just a 234 row database of all the different types of car manufacturers along with their model attributes, right? So the year in which it was launched, what is the mileage, the city mileage, the highway mileage, fuel type, and what type of vehicle it is, so on and so forth. We're using the same MPG package. We're using the pipe function followed by the group by function, right? So we are going to group it by manufacturers. This is like a simple pivot that you run on Excel with manufacturers in column. You're going to select both the class and the cylinders. So class is a categorical variable, so you'll have your compact, SUV, and everything mentioned here. And cylinders is either 4, 5, 6, or 8, right? And after you select, so once you select this, I'll just quickly show you what you get. you will get again the 234 odd rows with manufacturer, class, and cylinders, right? And then you're passing a pipe function, and this is where it gets interesting, right? So in order to understand this, let me just break this up for you, right? Now if you look at the cylinder function, okay, so if you want to find out the cylinder function, you have to first mention the name of the data set, followed by a dollar sign, followed by the column name. So what you see here is these are the 232 observations, and you can see that the first row has got 4 cylinders, the second row has got 4 cylinders, so on and so forth, right? Which is exactly what you see here, right? On the MPG database, you see the first row has got 4 cylinders, second, third, fourth. So now in this, let's say you want to understand what is happening over here, right? So you see that this is cylinder. Now if I put a minimum rank, right? If I put a min rank and then I put a MPG dollar cylinder, so what it does is, because you've got unique values repeating, right? And 4 is the smallest value, so it's going to rank it as number 1, right? So the smallest value is ranked 1, right? And because I've got 4 repeating so many times, you'll see that rank 1 also repeats n number of times, right? And after 4, let's say we've got 5 as the next level, right? So you can see that we have a 82 number here. So this is because there are 81 observations with cylinders is equal to 4. That's why R considers 5, the observation 5, if you want to rank it, it has a rank of 82. Now there are only 4 observations with with cylinders is equal to 5. That's why the next cylinder level, which is level 6, gets a rank of 86. And the last one gets a rank of 165, right? So it's essentially smallest to largest. It's basic ranking, right? Now, why have I ranked it? Right now, if let's say if I want to do exactly the opposite, if I want to rank it in descending order, I'll just write it like this. Sorry, right? I'll just write it MPG dollar cylinder, right? I'll just write it like this. So what happens is, earlier 4 cylinders had so wherever I had 4 cylinders, I used to get rank is equal to 1. Now wherever I have got 8 cylinders, I'm getting rank is equal to 1, right? And my fourth cylinder has got a rank is equal to 154. So it's actually done a descending ranking. It's actually the highest value gets the lowest rank. So highest value was 8 cylinders, it is getting the lowest rank, and the lowest value is 4 cylinders, it is getting rank 154, right? So what are we trying to do here, right? So what we're trying to do is, once we group all the cars by their manufacturer and just select class and cylinder, we are just trying to see what are the top classes with the highest value, highest number of cylinders, right? Which means the moment you rank it like this and then you use it inside a filter function and then you say less than or equal to 1, it just gives you the uh, top manufacturer with the highest cylinder. For every manufacturer, what is the most number of cylinders that you're going to get, right? So this is that function. The moment you do filter, and I'll just quickly show you how the results look like. Right. Right. And after this, we are just going to use a pipe function and just sort it based on manufacturer and by value of cylinders, right? And I'm also passing on a unique function so that we don't see duplicate values, right? When you run the code, what you see here is, now Audi has got just a single class, which is mid-size, and you can see that Audi, Audi, even though it has got n number of different rows with multiple cylinders, the maximum number of cylinders, the vehicle with max cylinders is 8. 8 is the maximum number of cylinders that Audi has. Similarly, if you look at Chevrolet, it has got two types of classes, SUV and two-seater. Both have got 8. If you look at Honda, it has got just a subcompact class. at least what we see on the screen, Honda does not have 8 cylinders. Honda only has 4 cylinders, right? So this function, essentially what we are trying to do here is we're just trying to see what are the top number of cylinders. I mean, we're just trying to rank by in descending order, and then because min rank usually has the smallest value. I mean, it assigns rank 1 to the smallest value. That's why we are using a descending, and then we're just going to pick up the top value, right? Let's say if you want to find out the uh, uh, top two classes for every manufacturer with cylinders, you'll just replace that one with two, right? So I hope this is fairly okay, even though it is slightly confusing. With this line of code, you can actually achieve a few things which you on an Excel sheet you would have to go through multiple columns, and then maybe do it in different layers, right? Now, there is also an easy way to do this. Instead of writing this complicated line of text, you can actually say top n one, and it will do exactly the same thing for you, right? Uh, I mean, you'll get exactly the same result. So, I just wanted to show you this function. So, if you want to use it somewhere, you don't have to remember this complicated filter min rank variable. You can just use top n, which will give you the top value in descending order. It will assign the highest rank to the highest value, right? So if you want to find out the top two items, you can just replace this by 2 and then run the code. And now you will see that there are two lines for Audi, right? One with 8 and one with 6. And actually you find three lines, because in mid-size, you're now getting two values, 8 and 6. I hope that was fairly easy, right? Uh, we'll also look at another function called as lag, right? And this is a very useful function. I'll just quickly take you through this, right? Let's say now we are grouping all the cars by their year of launch, and let's say we are summarizing the number of models. So what we're trying to do with this line of code, I'll press Control Enter. So what I get is I have 117 different types of models which were launched in 1999, and I've got another set of 117 models which were launched in 2008. Just to make this slightly interesting, because both these values are the same, I'm going to remove um, one row from the whole thing, right? So the way to do that is you put square brackets right after your data set and just say -1. So it will remove one row, right? Now if you rerun this code again, now you see that we have one model less in the one model. Earlier we had 117 models which were launched in 1999. Now because I have removed one row, we only have 1000 we only have 116 models, right? Now just to explain the lag function, right? Let's say I use the pipe function and then I put a mutate, so it will add another column, right? And I say that change, which is going to be the column name, is equal to models, which is this what you see on your screen, 116 and 117. And if I say models minus lag of models, what happens is, let me run this code quickly. um, I will actually get the difference between the rows sequentially, right? So 117 minus 116 is equal to 1, right? So I'll get the delta right here. So using the lag function, I can add another, and the mutate function, I can simply add another column, and it will give me a cumulative subtraction, right? It will give me the subtraction value, right? Hopefully this is a useful function, right? Right. So before we close, we'll just look at a few sample functions, right? So let's say you have a data set and you want to run a random sample of fixed number of rows. Now MPG, as we saw earlier, it was 234 different rows. Let's say you want to get a sample of maybe 5 rows. So what you can do is you can use the sample underscore n function after passing on the pipe filter. And let me just quickly run this. um, so what you see here is you get 5 rows, from your data set. These are randomly selected rows. As you can see, you get I mean, if you run it again, you get a completely different data set, right? So earlier you had 3 Nissans, now you don't have any Nissan. You have 2 Dodge, 1 Toyota, 1 Volkswagen, and 1 Jeep, right? So you can do this. Let's say you don't want to run a fixed number of rows, you want to get a fraction of the rows, then you can use a sample underscore frac function, and say, in this case I'm just selecting 5%. It had, I mean, the original data set had 230 odd rows. A 5% would roughly be maybe 12 or 13 different rows, right? I'll just quickly run the code. And I see that there are 12 entries, right? So this has taken a random sample, but 5% of the overall data set. So 12 different entries, which is 5% of 234, right? So you can use this function if you're in the audit org, or if you want to just see how I mean, if you want to just if the data size is too huge and you want to run a quick random sample, then you can use these functions to surface random rows or random observations for you. Now, I mean, the last function that I want to cater in the dplyr package is the glimpse function. So before I show you the glimpse function, I just want to show you the str function. So this is wherever you have a data set, right? The str function actually shows you what kind of structure, what kind of variable types or data types do you have in your data set. So for example, you'll start off with a column name, and then it will say that it is a character. It's a character vector followed by some examples, maybe the top 3 or 4 examples, depending on how it fits the screen of that column, right? As it goes down, you can see that there are some data wrapping issues, and it might not be easily readable or consumable if you use the str function, but generally people very commonly use the str function. In dplyr, we have got an alternative, which is a glimpse function. If you want to quickly understand what your database, how your database is, this has got better data wrapping compared to the str function, as you can see here, right? This will show you all the different columns. It will nicely show you how the different data types or vector types are. You can see characters, integers, factors, so on and so forth. And it also delimits all your values by comma so that it's easily readable, right? And it does not have a fixed value. For example, let's say your trans column, it only caters to 5 values, whereas if you look at the number of cylinders, it caters to n number of cylinders, right? So it actually is a very neat function for us to look at. Hopefully with this function, we have looked at video 5, 6, and 7. Between the 3 videos, hopefully I've covered most of the basics of dplyr function. In some of the future videos, I will try to cover some real life example in terms of how you can use dplyr along with plots, or if you just want to do a simple table-based analysis, how to use dplyr. So we'll take up those set of examples in future videos. Thank you very much for watching. Hope to see you in the next video. Cheers.